Ortho, phosphorus in water. What is it? Is it a problem? How do we know it's there? Taking a look at ChemScan, we're going to find out. So phosphorus analysis can be classified as a type of pre-processing performed on sample, and phosphorus may be found in several forms in water or wastewater, including dissolved form, that's going to be orthophosphate, in organic form, reactive plus, condensed or acid hydrolyzed phosphate, and in organically bound forms. Total phosphorus is the sum of reactive, condensed, and organic phosphate. Total phosphorus TP is the form of analysis typically cited as an effluent parameter for municipal and industrial wastewater treatment plants, and total phosphorus in effluent is a measure of remaining dissolved phosphate plus any soluble phosphate carried over into the effluent in form of precipitates or within microbes. Following digestion, all phosphorus is converted into dissolved phosphate for analysis. This is, however, not the form of analysis that is most useful for processing, monitoring, or control purposes, because total phosphorus analysis does not identify the original source of the effluent phosphorus. The most basic form of analysis for process control is reactive phosphorus, orthophosphate, which can indicate the amount of phosphorus that is available to participate in chemical reactions or biological activity. This concentrate can be measured before and after chemical precipitation or biological assimilation and settling, and measurement or dissolved reactive phosphorus requires the filtration of the sample of 0.45 micron prior to analysis. And then what is the ChemScan initial method? Well, they took the method for orthophosphate analysis based on the vatodomilobide phosphoric acid method, and the ammonium malodobate reacts under acidic conditions with orthophosphate to produce mobilitic phosphoric acid. Further reaction with vanadium produces the vanadium-mospheric acid, which has strong absorbance spectra into ultraviolet and visible wavelength range. Dissolved orthophosphate analysis is performed on a filtered sample. If the sample is not filtered prior to analysis, any acid absorbalized phosphate precipitates or precipitate in the same way may be redissolved and detected. Online orthophosphate analysis using ChemScan can also be performed based on the precipitation of orthophosphate with a known concentration of iron salt, followed by measurement of residual dissolved iron. Liquid ferrous chloride is a reagent of choice, particularly in wastewater of a pH of 7 to 8, and in lower pH samples may use liquid ferric chloride. Higher pH samples may require buffering in acid in the iron salt solution, and the reaction between ferrous chloride and phosphate can be approximated with the following equation. Also, the ChemScan process analyzer must be set up and characterized with any background in iron concentration, and the analyzer must be calibrated to compensate the effects of variable sample turbidity and possible interference with nitrate, sulfate, chloride, bromide, and organic matter and other metals. And the sample extractions are a function of the phosphate removal process as well, and it can accommodate these different samples. So taking a look at this, we can understand orthophosphate in water and how it's analyzed, but how do we know if it's high in the water content we have right now? Well, we can use different equations, we can take a look at scans, but really the only way is to test it. And the best way to really make sure your water is safe is to test it for high levels of orthophosphorus.